We are in your foldable again. I hope you have it and you found the rhombus page on the cover sheet. Let's check out the definition. So a rhombus, it's already under the parallelogram. I'm not going to write all these down, but you need to make sure that you know that since it's a parallelogram, it has all those properties that we saw above. Parallel sides, opposite sides congruent, opposite angles, all that good stuff. But what makes it special? Well, rhombus has 4 congruent sides. Now, a parallelogram has 2 pair, but what we're saying here is a rhombus, all 4 sides are the same. So we're going to only need 1 tick mark on each one that show that all 4 are a match. So if this guy is 10, this is 10, this is 10, this is 10, all the way around. And if you'll flip it open, we'll look at some of the special properties of a rhombus. Those 4 sides being congruent makes some special stuff happen, particularly with their diagonals. Our first special property tells us that the diagonals are perpendicular to each other. Okay, let's look at that. I'm going to have my first diagonal is a long one, and my second one is a shorter one. But when they cross, what's happening here in the middle? Well, they're crossing to make a right angle. Of course, that's what perpendicular means. So right here where they meet, we have a nice 90-degree angle. We've got a set of 4 of them actually right there. And you'll notice we've got 1, 2, 3, 4 triangles. All of those are right triangles. Excellent. Write it down. Another special property in the diagonals is that they bisect the angles of the rhombus. We draw just this one diagonal. I just bisected these angles over here. So I would like to show that in your diagram. This angle and this angle got bisected. Now remember, these opposite angles are the same in all parallelograms, so these guys are the same. So I get 4 equal angles. Same thing occurs on the other diagonal. If I draw this diagonal in, I just bisected those angles there. So let's put those in there too. You want to show that that angle there just got bisected into 2 equal pieces. Its opposite angle, which was a match, same thing, 2 equal pieces. So 4 angles on those corners, all the same. Let's try some out. Oh, here's another one of those. We have to draw our own picture. So we're going to draw a picture of a rhombus. Let's sketch that. You're going to want to make it look like all 4 sides are the same. Do your best. Of course, we're going to tick mark it and remove all doubt. So let's put our tick marks on there. So here's my 4 equal sides, and its name is Rhom. So R. Around. Remember, you're going in order around this thing. R-H-O-M. And R to H, they tell us from R to H, right up here at the top, 6y plus 4. And then from O to H, that's 5y plus 8. Oh, one more. O to M. Right here, 3y plus 16. We get to find M to R. Well, we already tick marked that they're all the same, so we got to set up an equation here. And if I hadn't known it was a rhombus, I wouldn't know what to do. But since it's a rhombus, I can set any of these sides equal to each other. I'm just going to take my first 2. You might try a different pair. See if you get the same thing if you try a different set. But I'm going to go 6y plus 4 and set that thing equal to 5y plus 8. And then let's solve this. So if I subtract off, I'm going to take the 5y away from this side, take it from this side also. Yeah! There goes my ninja. Let's bring the 4. Let's take that over here by subtracting 4 from both sides. Yeah! Starting to lose my voice. Can't do that yelling so much. Okay, so what do we have left? 6y minus 5y. That's just 1y left. And over on this side, 8 minus 4 gives me 4. So my value of y is 4. When I plug that 4 into all of these, I better get the same thing. 6 times 4 is 24, plus 4 makes 28. 5 times 4 is 20. 20 plus 8 gives me 28. It's a good sign. Last one, 3 times 4 is 12, and 12 plus 16, you guessed it, 28. So let's see, I don't know, what's M to R? Yeah, it's not tough, 28. M to R is 28. Awesome. Next example, the diagonals of a rhombus. They didn't draw it for us again. The diagonals of a rhombus are 10 and 24. We get to draw our own picture. 1, 2, 3, 4 sides all the same, with diagonals coming in across here. The long one, that's 24, and this short one, that's 10. Now, that's going to be hard to draw, but remember these are getting split equally, so On my short one, that's 10. Let's just write in its pieces. It'd be 5 here, 5 here. And then my 24, that's my long one. In parts, it's going to be 12, half of it there, and 12, half of it here. We get to find the length of a side. Okay, let me show you how this is done. Find the length of a side. Wow, I don't know, those longer sides. It's not 5, it's not 12, but here is the trick. There's a right angle. The diagonals of a rhombus make right angles. So that means there's some right triangles in there, and I'm going to draw that out separately. So here's my right triangle. One side's 12, one side's 5. There's the right angle. Pythagorean theorem to the rescue once again. A squared plus b squared. What does it equal? You got it. C squared. Okay, let's check it out. This time the C is the unknown side. That's my question. So I'm going to put X in that spot. 12 and the 5, those are the other sides. 12 squared plus 5 squared. Okay, let's work it out. 12 squared, 144. Everybody knows 5 squared is 25. And that makes a combined total 169. And what do you get when you take the square root of 169? Well, you get X. What else do you get? What is the square root of 169? That'd be 13. Okay, so X is 13. And X, remember, X corresponds to this side here. I probably could have put that down there. X is right there. So X is 13. That's my answer. One side is 13. They're all 13. Angle time. I like doing angles way better than sides. Okay, so remember, we've got a diagonal. Gonna highlight it. This diagonal right here. What's it doing to those angles? It's bisecting the angles. Something you also might want to do is put those tick marks on there where you have the congruent sides. 4 of them. 1, 2, 3, 4. Okay, well, check it out. This is a triangle with two sides the same. I think we have a name for that. Can anybody say isosceles triangle? And that means these angles right across from those two sides, those guys are equal. So if I want to get, say, angle 2 right here and angle 4 right here, here's the way I'm going to do it. I'm going to take 180 degrees that are in every triangle. I'm going to subtract out that 104. What's that come out to be? 76 degrees. And then if I'm going to split that equally among those two angles that are left, since they're equal, I'm getting a whopping 38 degrees, guys. So angle 2, that's 38. Angle 4 up here, that's 38. What about angle 1 and angle 3? Well, these guys, remember, these were bisected. So, yep, other half of it, 38. And right here, 38. That's just one way to do it. You might have a different way. But every single one of those angles is 38 degrees. I think that's cool. Yay, another angle one. I love these. Now both these diagonals are drawn in, so I'm going to do what I like to do right here on diagonals for a rhombus. Remember, they're right angled. Diagonals are perpendicular, so that tells me angle 2 right off the bat is a 90-degree angle. I also know these are 4 right triangles here. Let's take that 58. Remember, this is bisected, so this other piece right here would be 58. And on the opposite, these guys, that's 58. This one's 58 as well. So we got angle 3. We've got 4 58-degree angles. Add that in there. What are we going to do about angles 1 and 4? Well, there's a lot of ways we could go about this. Here's what I'm thinking. I'm going to say, let's just take this little triangle right down here at the bottom. And that triangle we can do some calculations on. Make a note, this is a right angle right here. So I've got a 58, I've got a 90, one angle left. Let's take 58 and 90 and combine them. What's our total with that? I'm getting 148. So we've got 180 total, of course. We'll take away the 148. We've done these kind of problems before. How about 32? What do you say? 32 degrees for angle 4. Guess what angle 1 is then? 32. I know they didn't ask for it, but you might as well put it down. These guys over here are 32 degrees and 32 degrees. 4 of those. Love it. All right, so 32, 32. That's all there is to rhombuses. Those diagonals do a lot for you. Do the try these.